My name is Butch Taylor. I'm a senior software engineer, architect. I don't know what I am at Accusoft. And I'm going to be talking today on microservices and testing and, of course, Node.js, because that's all anybody cares about. Okay, so Node.js, microservices, and testing. I thought I'd start with a little bit about me, random things about me that don't make sense. First, and some of you already heard this, I've been at Accusoft for 29 years. Accusoft was founded 25 years ago. So that doesn't make sense, but I was bought 12 years ago. Jack bought the company I was working for and let me keep my years there. So sort of 12, sort of 29. My wife is Chinese. I don't speak Chinese. And I don't like Chinese food. So that's been a problem. If you don't know, Chinese people are actually kind of proud of their food. And so
if you go to China, then it's just food, right? So you'd be okay.
Yeah.
I don't like food.
In France, they call them our fries.
Yeah. So I'm a JavaScript developer. My first program was in machine language. In fact, it was on this computer right here, so you can see it's.
Oh, you brought it.
I did, yeah. Not super sophisticated.
Is that the exact one?
Yeah, this is my first computer.
Did you use ones or did you use zeros?
I used hex actually, so I'm good at hex. But anyway, it's got like 1.1K of RAM. So you guys have heard of LeftPad, I'm sure everybody knows, like 6 lines of code. The index.js for LeftPad will not fit in this RAM because it's 1440 bytes, including comments and things. So that's how small this thing is.
Z80?
It's a 6502, same as the Apple II and Commodore and a lot of things. I also brought, since I have them sitting here, 2 magazines. If you guys looking for something like really funny from 79, these are quite funny actually, to see what people thought was cool for computers. So last one, I'm a software architect, and I'm presenting on testing. So that seems kind of stupid. But maybe what's more interesting is you guys drove here to listen to an architect talk about testing. Gave up an evening.
Some of us walked.
Well, that's true, yeah. But you're stuck here at work. So anyway, it sort of makes sense because, in my opinion, everybody on Earth is an expert at testing. So it's largely just my opinion is this, and your opinion is that. So, but it makes for fun conversation sometimes. And you got an assignment. So just pick something when I'm talking about it, say, well, whatever, that was stupid. And feel free to say it while I'm talking, I don't care. So anyway, topics, I'm going to talk about some of the tools that Accusoft uses, some of our practices, opinions, of course, because that's, like I said, a lot of what testing is, and some lessons learned. Here's some of the tools, test frameworks, MOCA and Yada. I don't know anything about Yada, so ask somebody else about that. Test helpers, Chai for expectations, sign on for mocking, rewire, and some mockery also, but rewire is kind of cooler, and knock. Probably you guys have used some or all of these. Measurement tools, Istanbul, we use that for code coverage reports. ESLint for static analysis. And then some miscellaneous Gulp for our build process, and Webpack for a build process, and actually NPM scripts for a web process, build process. We use Console for having our services interact with each other. So services will advertise their port and everything on via Console, and then other services will look that up in Console and be able to interact with them. And TeamCity for automating our builds. So first thing,
Use for UI. I know we're not covering that. But.
UI. So that varies. We're doing a lot of work now in React, which I like React, but I'm even further from being a UI guy than I am a testing guy. So probably a lot of things. We've done a lot of stuff in the web space for many years, and so we've used a variety of things. But lately, it seems like we're moving to React. If you got other questions, feel free. I'm pretty informal. So linting your service code and your test code. Don't stop at your service. I'd say fail to build on lint errors because there's a chance that it'll catch real errors. What do you do about lint errors on dev machines? Do you just accept like console.log and let other things fail builds? Do you just ignore all errors? Do you skip lint entirely? I would say maybe skip lint entirely. Nowadays, all the editors will have some linting built in, and so you can rely on the red squiggly under something to give your developers an indication that something's wrong. Meanwhile, that they can stick stuff in the code that would cause linting to fail in order to track down a problem. And then as long as you catch those on builds, then it can't get into production. Linting helps you find bugs, and that's really good. Linting will also help you enforce style, and that's more of a choice that you have to make. Do you want to enforce consistent, so I'd say probably enforce consistent indentation, but do you want to handle curly braces a certain way? You want spaces in front or after or parentheses or whatever? That's going to be a choice that your team makes, whether you enforce that or not. So the next thing we use is MOCA. And how many here have used MOCA? Okay, so lots of you guys use MOCA. So maybe you'll find some of this boring. But MOCA, basically, it's a hierarchical thing where you have describes to describe groups of tests and its to describe specific things. And there's before and after syntax. So here's like a puzzle for MOCA. So when do these console things run? Now, how many people would say that A runs first? Yeah, A runs first. So that's an easy one. How about second? Which one runs second? Because this is the source of a lot of problems, actually.
Would it be G on there?
It's not G. It's C. My things don't line up anymore. I don't know why. Pretend that's up a little higher. So C, yeah, a common mistake is to think that I can write this code at the top of my describes and assume that B, my before, has already run, but it hasn't. The first thing that MOCA does is it runs through all your functions and builds up an in-memory tree of your tests. And so that causes A, C, F, and G to run. And then it goes through the tree and runs your test. So next would be B. And then the only test that's actually in here is E. And then the one thing that says run after the it runs last. So that D would be last. So anyway, it can be kind of tricky, especially early on, to figure out what is MOCA doing and why do my tests sometimes fail. But this I think helps if you know exactly what MOCA is doing for ordering.
Can I ask a question?
What's that?
Can I ask a question? Does the
Sure.
before run once per it or once for the describe?
There's a before and a before each. So the before would run before the describe. If there were a before inside the describe, then the before outside would run before that one. And then if there's a before each, then it will run before every it. And so I find that to be a little wrong. I would prefer the before each outside of a describe. If you had like multiple describes, that it would run only before each thing at the next level. But actually it goes all the way down to the bottom. If you have nested describes and its, and it'll run before every it. So sometimes it can be surprising that it runs before things deep down in your hierarchy. Any other questions? So here's a common problem I see, and it's also a MOCA problem. So MOCA allows you to pass this done function to your test code, and when your test code is done, it calls the done, and then it moves on. Well, in this case, the done was called here at the bottom of the function, but before this request completed. And so what's going to happen here is if the expect succeeds, like your test is okay, everything's all good. But if it fails, this before is finished. So it's going to fail in a different test somewhere. So you see a random test that comes after this point, fail, and the stack trace will tell you that it's here in this code. And you're like, why did that happen? And that's because you called the done too early. So this, I see this happen quite a lot. And it's very easy to make this mistake. So next thing, this is my, my development cycle for Mocha. I've got some test and it fails, so I find the failing test. I change it to it only, it.only. That tells Mocha, only run this one test. Because I don't want to run like a 5-minute test suite just to find one problem. And if I know which test is failing. And that also makes more likely that the problem code is actually inside that it, or one of the befores. I modified the service code, the test code as needed to correct the problem. I committed all the source code, source control. Does anybody know what the fifth step is?
Get rid of the only.
Yeah, revert that back out of your source code. Because you probably committed that to Git, and I do that all the time.
I think we just had that happen last week.
It happens all the time. It's a very common problem. So there's actually a sixth step now. There's an ESLint plugin that will reject that. So go install this plugin, and now your builds, you can still commit it to source control, but at least it won't make it into production. Or you will know it early on instead of, my tests have been passing for a while. All the time. Yeah, my test. Yeah. So anyway, I highly recommend that. So here's another problem, and this is kind of annoying actually, and the workaround's even annoying. So suppose you're writing this code and it's in your service, and so it's a fairly common thing. You got a function, it does some asynchronous thing, and then finishes up the asynchronous operation and calls the callback with the result. And so you write this, and it sort of works. In fact, it works. And somebody says, well, there's a chance that ... do stuff, that might throw an exception. And so you want to write a try catch around that. So that'll catch your exceptions and then call the callback with the exception. And so now everything's kind of nice. If something bad happens and you get the error callback, at that callback result, that should be undefined comma result. That's a bug in my code. So ignore that. Okay, and then also maybe the do stuff, it doesn't just like do a bunch of stuff and then call the callback at the end. Maybe it has like a few cases, and sometimes it'll call the callback early. And there's a risk that maybe you'll call that callback more than once. You don't want that. So you add this thing with Lodash, where you have this one-time function. And so now your callback's only going to be called once. So it will either be called successfully or with a fail. So now you're happy. And now you try to test it. And so you write this code here. So it works correctly. By the way, works correctly is not a good description for a test. Don't use that. So basically, you call the function and you expect some kind of result, and you say done. So now that the asynchronous nature is handled correctly because the done's inside the callback. And this works as long as your test is working fine. But if your test is not working fine, then it times out instead of reporting that expect. And that's because that expect, how it works is it throws an exception. And if you look back here at this code, the callback for the OK case is inside the try-catch block. So that try-catch block catches the exception and calls the callback again with an error, but it can only call it once. So it just drops out. Now nothing's running. You had an exception that was thrown. This just gobbled it up. And so in this case, you'll see that test failures result in a timeout rather than the message you expected. If you see this happening, you can fix it like this by adding a try-catch inside your test code and calling done with the error instead of just letting that error propagate up, because it won't propagate up. And we're using this in a lot of places just to work around that one problem. So Chai, any other questions on Mocha? I'm going to move on. So chai, we use chai for our expectations. I hate it. And I have a slide on why I hate it. I really like it. I don't like the assert syntax that a lot of things use because it always seems backwards to me. So I do like the expect syntax. But there are some very small specific problems with chai. So the chai lets you say expect something to equal 42, compare objects. It'll do a lot of things to say what the type of the thing is. There's also an assert syntax with chai, so you can do both if you want. So who knows what this does? Who here uses chai? Okay. Does anybody know what this does?
Anything that evaluates the true?
That seems to be what it does. Actually, in truth, it does absolutely nothing.
What?
It does nothing at all. It's not an error. In no case will it ever throw an exception. Because there is no to be truthy. So this is basically evaluating to undefined. And with this syntax, if you have undefined semicolon, that's valid JavaScript. It's pointless. So anyway, that is why I don't like chai. It's because it has this syntax where at the end you don't need parentheses. You can fix this by saying expect value 1 to equal something true in parentheses, and that will do what you want. And if you misspell to equal, then that will be an error. But in this case, you misspelled that last thing. It's not an error. It's fine with that. I spent like an hour tracking down this problem. My test should be failing, but it's not. So anyway, my workaround for that is I never use this syntax. I always use something with parentheses on the end because that will cause an error when I misspell it. Sign-on or sign-on, I don't know how to pronounce it, so I'm going to call it sign-on. We use this for creating mocks. It's really easy to use. You just say create me a spy or create a stub. You can tell it then if you create a stub, you can tell it what it returns whenever you call it. You can say the first time it's called, return this. The second time it's called, return that. It gives you a lot of flexibility. And then afterwards, you can inspect it to see what happened. So you can say, well, expected it was called one time. It has some helper functions. So that second one there, assert spy called once. That just basically is a shortcut for call count equal 1. And you can say, you can also look at the arguments that it was passed. So you can say, well, the first time it was called, the first argument should have been magnificent. And the second argument should have been 7. And so it gives you the ability to really look deeply into your dependencies, what you're doing with your dependencies. I would maybe question whether you really wanted to do that. So I find that a lot of times I'm tempted to do this because sign-on makes it really easy. But now my test code is really fragile because I'm making assumptions that can very easily change in the future. And maybe honestly, I didn't care so much about those. I just wanted to make sure that it was doing what I wanted. When maybe I don't care about what it did to a dependency, just as long as when I called it, the result I got back was right. So I really like sign-on, but I would say if you're using sign-on a lot, you might consider how much detail you're putting in your tests that you don't need to have there. And there's a lot of discussion on the internet about how much mocking you should do in things. Even to the point that some people say, well, I don't hardly use any. I think a lot of times it's, so if you're using sign-on, a lot of times you're implicitly saying that the unit I'm testing is a function. It's like I'm testing this one function, I'm mocking its inputs and everything. When maybe you don't care about testing one function, but you care about testing a whole module, a .js file. Or perhaps even you have like a collection of 3 JS files and you don't even care about how they talk to each other. You just care that as long as you call this one, then I get the right results. And that's a judgment call. how you want to define your units. Nowadays, I feel like if I have a module that does actions, and I have some other things that basically represent data, just kind of static data, I used to mock those data objects, and now I don't, because the data object itself is a sufficient mock. And if I change properties on that, then now I no longer have to make the same change to my mocks.
So, Chai is described as a BDD tool, though. But would you really call it a BDD tool? I mean, I would say you're doing unit tests here. You're not doing BDD.
Would you say it's Chai?
Yeah. It gets described as a BDD tool, but I don't think it is.
I think you can use it. I think a lot of those terms end up being kind of artificial. I myself, I don't care so much about precisely what category of thing I'm testing or the approach, as long as I'm testing and trying to test behavior that I care about, and not so much the implementation.
Well, I guess my definition of BDD tool is I can have a conversation with a non-technical person about it, and you say, when we do this, we expect this, and you get this result, and they understand that.
Mm-hmm.
I wouldn't expect a technical person to understand this at all, a non-technical one.
Right, I would agree that actually, and I would say that everything I'm talking about here is really not very approachable by a non-technical person. So MOCA is really not.
Yeah.
They could maybe read the test report, but they're probably not going to read the code itself. And so the specific things and the structure, I'm not sure is that important. But I meant to say that at the beginning, that this is definitely really developer testing that I'm talking about today. And I'm not a terminology guy. Maybe you can say that's where I fail in not being a QA person. So the next thing, any other questions on sign-on? Okay, so dependency injection. This is hard. So say I've got this module I want to test. It requires FS. It writes to a file. I want to test it, but I don't want to write that file. So I have some options for how to do that. So some good and some bad. Well, for one, I could just go ahead and write that file and live with it. But usually there's some reason why I don't want to do some of these things. So I could actually, in my test code, oh no, this is the module under test. I could export that FS and just make sure I always use that. And that allows my test code then to load this module, swap out _FS, and have it behave differently. That's icky. And it's also very error prone for a lot of things. You can accidentally forget to use export.fs. Maybe not for FS, but for some other things, like say if you had a set timeout or other things that are globals. It's really easy to forget to use the exported one, and then your dependency injection doesn't work anymore. And this is another approach for some dependencies where you, in your test code, require FS, and then you go in and change that write file function. You have to save the old one, but you change the write file function. Now you've changed it for everything. The entire process can no longer write to files. And hopefully you just do that for a really short period of time, and no one actually needs to write to a file while you're writing your test. But your test can't write to a file either, unless it uses the other one. And then you do the require, and then you can swap back at the end of your test. There's this module that Michael told me about called Rewire that is really cool. In your test, instead of requiring, I got that wrong. Ignore that first line of code. I deleted the wrong one. You're supposed to say var rewire equals require rewire. But you require the rewire module, and then you use rewire instead of require. Yeah, that is hard to say. And now that module under test has functions that let you change all kinds of things that you would not normally have access to. So if there was a function in that module, a global variable, you can read and write those however you want. So it gives you a lot of control over that module. And this, again, is kind of similar to my comment on sign-ons. That if you find yourself doing this a lot, you might be testing in too much detail. That's just a choice that you have to make. And then, of course, revert at the end. But rewire makes it really, really easy to do this. That's not right. Okay, there's also mockery, which allows you to do some similar things, but it's harder to use. So I would recommend rewire over mockery. But we were using some of both, actually. Any questions on that? Okay, so my next topic is on, I don't know what to call this. But anyway, so your service is basically a collection of units, essentially by definition. And they interact with each other. They call each other. And so you've got like an entry point, which is probably an HTTP or RESTify or Express at the top. And there's handlers at the next level down, and they call other functions. And ultimately, everything is called in your service by something. Some of these things are really easy to unit test, and some of them are not. So without having any more detail, there are a few of these that you can tell just from this call tree are probably easy to test. Somebody want to guess what those are? The ones that don't call anything, they don't have dependencies you need to mock. So these are really easy to test, generally. There also sometimes tends to be a lot of code in these. So you can get some code coverage. The rest are kind of hard to test, especially the top one. That one can be one of the hardest to test. But it turns out that that's actually one of the easiest to test if your test is just to make calls into your service. So if you're doing unit testing, real unit testing in process, loading this module with require or rewire, calling its functions, these green boxes are easy to test. But if you have a separate MOCA process that's calling into your service, then the top one is actually the easiest to test. And so we do that at Accusoft. We have both these kinds of tests, and I consider them kind of flavors of unit testing. That there's some dispute, but either way, we do these kinds of tests. And they're kind of nice because the top is easy to test that way, and the bottom is easy to test with unit tests. And so you can combine those. These are, say, the ones that are easy to test. If you call it from the outside, you get probably good code coverage for the top, and maybe the second level, you get really bad code coverage for the bottom level, because you're probably just like calling the happy path on all those. But you get a different kind of code coverage, but still low. But we have a build process that does both of these, runs an Istanbul report on both of them, and combines it. So you end up with, you can do easy tests and get moderate code coverage because we're testing both ways. Now, that's still not good code coverage, but you've done easy tests. So now you just have to look, at this point, if you wanted, you could look at the Istanbul report and see which things are not being covered, and then go add unit tests for those. And I think this produces better results. But this is something that you can do with microservices that you could not have done with a big monolithic service. Because the big monolithic service is just a giant collection of units, and those units aren't really accessible from the outside. So you have little choice but to unit test them. And this call tree is a lot bigger. So I think that this is one of the real benefits of microservices, is testing smaller things. And so this is a little bit about how we test things. So we have, say we got a service we want to test. So this is when we're testing from the outside. So we've got a couple services that make calls into this service. So it exposes, of course, an HTTP API. It makes calls to other services to fulfill those requests. It also interacts with our infrastructure, console, PM2, maybe some other things to fulfill those requests. it's actually non-trivial to test that service in isolation. But it's very valuable to test it in isolation, because if something goes wrong with this service, I would like to know that it's this service, not that some request far away failed because this service has some weird problem. So we actually have a test harness that allows us to mock a bunch of this stuff. So now our test code is now the only code that's making requests into the service under test. We have a mock version of console that has just enough of console to support the service under test. And then a mock PM2 to start up the service appropriately. We have a tool that's very similar to knock. You guys have probably seen knock, that allows you to simulate requests outgoing from a process. This is actually the opposite, where I can use basically the same knock syntax and it will set up a web server, a real web server, attach itself to console so that when the service under test wants to call this dependent service, it actually calls into the test server inside the test code process. And so it makes it very easy, or a lot easier than to test a service in isolation without any of the other services being up and running. So we also have some internal tools. Here's a really small one. We have a little module with some test data. So here you see it being used. You require it, and it has just a collection of a whole bunch of different lists. So if you have a function that requires an integer and it should fail if it's not an integer, then you just say, we'll use the non-integer values. And that array has a string. It has like a number that's not an integer. It has null in it. It has undefined. It has an object. It has a regular expression. It has a function in it. And so then it's very easy to just iterate over that, make sure your function fails. And if it doesn't, then you're good. So you don't have to worry about, in this test, creating a list of things and forgetting to add a string or forgetting to add a non-integer value. And we have the same thing for if it requires a function, then there's a non-function values array, there's a non-object values array, non-string. We have a variety of those. So that's basically a really simple way to just make sure your tests are always consistent and cover the cases that you want to cover. More information. Most of these you can just Google ESLint and you'll find it. It's pretty easy, especially ESLint. Chai, maybe not. You might find some other things before you get to the real chai. I did want to show one other thing. So this is a test report that we get from our service tests. And so it looks a lot like a MOCA report. It's actually not. So I can go up here and change it. So I want to see the skipped tests. So that will then filter down to everything that in the end was an it.skip or was part of a describe.skip. Or I can say, show me the failed tests. And not only that, but I can go and click on one of these. And now I can see that this is the test, and it called my service. And I can look and see what happened. Here's the logs for that test. And so it's basically saying I made this call for, well, hang on, I'll go back. When handling post document conversion service, delete context. I got a 404. That's not good. If I look into the log for the service, I can see it was called with contest. So that's just an error in the test code. But because that string is present twice in the test code, that's an easy mistake to make. But anyway, this allows us, this is a tool that, it's a special MOCA reporter that runs during the test to collect the structure of the test and save that to a log file. And then there's a post processor that takes the services log file and the MOCA test log file, combines those, and then this UI. There's also this other tool that lets you see. So sometimes we have, I've seen one case where a log file had a 1.5 megabyte single line because they were just JSON.stringifying something that was bad. So that lets us see that. You can also see relationships between services. So you can see that this request to create a context ended up calling these other dependent services. And because they're mocked, then it's really easy for us to capture that relationship. And then these other incoming requests didn't result in any calls to dependent services. So this allows us to see the structure and sometimes see things that we didn't realize about our own code. Sounds like we're done. Thank you, guys.
Okay.